Hello.
Hello,
Hi. How are
I'm good and you?
you? Okay. We have Adama and Sarrah and Morgan. Hello.
Hello.
Hi. Okay, so why don't we get started? Um, so let's start with updates. Who wanted to go first?
I can go first.
Okay.
So since last time, I make some advance on the IGE code panel. I can share my screen.
All right.
Uh, let's here. Okay. So can you see my screen?
Yes.
Okay, thank you. So first, share you the main screen. Scene, sorry. Here. So here we have all the assets for the game coding game.
Okay.
So I didn't implement yet the game, but what I did was to create the core the core of the coding panel. So it's basically the user has to drag and drop some code elements into this panel with his controllers, and then on here he will see. Maybe I will add a button execute, and on here it's like the PowerShell or the results of the code. And on other panel, he will see some challenge and other indication. I can show you how it looks like only the panel because I didn't connected it to the VR yet, but just a second. Okay, so it's here. Everything is not working perfectly yet, but I'm working on it. But yes. So here, this should be like some blank spaces, and the idea is like the user takes some code here and just drag and drop on the panel, um, and he can just put some code element here. Here the number should be like some blank spaces, and yes, so that's what I implement since last time.
Okay. So what is this for? The code ID? Is this for like?
So the idea is like the user has an indication, the problem to resolve, and he has multiple code. For example, go right, go left. If his problem is to go from a point A to a point B, and he can just drag some codes, put it here, and here the number is like the indentation. So like in Python, for example, if you put here or if you put here, the code will not work in the same way. And I don't know if I was clear.
Yeah. So this is like part of the game where they're trying to solve a problem and they're moving
Yeah.
things around the interface.
Yes.
Yeah. That looks good.
And for the moment, that's it. And I have to work to connect it and to make it how to create some task for the user and
Yeah. Yeah, that looks good. Thank you, Adama, for that update.
thank you.
Yeah. So, what are your next steps? So, you have to work on connecting it to some tasks.
Yes.
Okay.
Just fixing make the ID working well, and then create some task for user to resolve.
Okay. Yeah, that sounds good. Yeah, then I look forward to seeing that update. So, are you having any problems or challenges in doing this, or is this just? I mean, everything's been pretty well. You know, you haven't had any major problems.
What do you mean by problems? You mean the problem by implementing the things, or?
Yeah, I mean, implementation wise, or any sort of like problems with compatibility of things or asset management or any of that.
Not for the moment, not big problems. Um, and yeah, not for the because I'm still learning. So I found when I have a problem, I look on the internet, and so I found some ideas to resolve it. So I do not have some problem that blocks me for the moment.
Okay, well, that's good. Yeah. Thank you again for your update and look forward to seeing the next update and progress on
Yeah,
that. Yeah.
thank you.
Sarrah.
Yes, hi.
Hello. Hi.
So yeah, I wasn't able to attend last week's meet, unfortunately. So I posted a message on the Slack. So I'll just start from last week,
Okay.
kind of what I was doing. So before that, like the last time I spoke here, I had finalized a design, and I had written some code to create some like basic agents that could look at a pull request and kind of understand what kind of code needed to be written. So then the week after that, I needed to like to model this as an agent-based modeling. I need to create an environment sort of that the agents will kind of interact around. And being an open source project, like the environment should be an open source repository of code. So the main challenge is not the environment. Like the environment can just be a bunch of files, but the thing is getting the agent who is supposed to be kind of an open source contributor to look at these multiple files inside of a repository instead of just looking at like one piece of code, because they need to be able to like navigate that. So that is kind of the direction I was in the past 2 weeks, where trying to create this environment. Last week I initially did some research because there are I came to find that there are frameworks that have solved this like exact problem, kind of. So I found three papers that I linked on Slack as well. And then among these, like I realized that this paper eventually uses the other two papers. Like it has half of one framework and half of another framework. And then these are the two main papers, like these are two main frameworks that are done to kind of make an LLM go from an LLM to a proper software engineering or sort of contributor agent. So the first was SW agent and the second was autocode rover. So autocode rover came later, and so I decided to kind of use this as my framework. And so basically, like what this paper kind of does is, as I said, the navigation of different files in the repository. As I simulate my open source repository, more and more agents will write code in different files. And so every time an issue needs to be addressed, the agent needs to be able to kind of browse the entire repository. So actually what all of these papers are based on is a whole data set called SWE agent, SWE bench, which is a benchmarking data set which has a lot of GitHub issues that these agents try to solve. So like they definitely work, and I mean so I had a meet with Himanshu the week before last, just a very short meet where I was kind of looking at these frameworks, and I was trying to understand as to like what is the kind of extent that I need to go to within my project to achieve this. Like I don't think I need to be able to solve any GitHub issue anywhere because we're just simulating it. So what I kind of settled on was that if I have a toy repository, which is a sort of basic repository, and the agent can get through it, it's like enough to simulate our environment. So basically, I'll just illustrate the working of this with like I ended up creating this like toy repository, which is very basic. It just has like two files. It has a calculator file, which just has like 4 basic calculator functions, and it has 2 issues. So now when I give this is the kind of issue that I input to this autocode rover, where it's like very much like a GitHub issue. It's written in Markdown, and it says that what kind of example code is kind of expected and what is the exact description, what needs to be done. So the first was a creating issue. Like I said that there are 4 basic functions of add, subtract, multiply, divide. So add a trigonometry function. And what the autocode rover framework does is, the main thing is it has these search APIs where just like a normal person would, like if I as a normal person go to a repository and I need to solve something, I would go to the I would try to search the specific functions and classes. So it has these similar search APIs to kind of search class and search method. And once it does that, it gets the exact code file, and that code file can be given as context, which is important in LLMs. Once they have the appropriate context, they can write the correct code. So basically, this is just a run through where the first it does is identifies which APIs it wants to use based on the issue description. It wants to use search class, search method, and then it kind of gets the results of the APIs that it has called, and it figures out that there is actually the class that it searched for, it is there and it is existing, and what is the exact file path to the file. It realizes that like, so this was an issue to create the sign method, and it realizes that the sign method is nowhere present. So, and then it comes up with like observations that it needs to like actually add a new method, not just fix something. And once it has done that, it identifies the exact file locations, and then it writes here. So it writes code, and basically it has a specific structure to write the code, and based on the structure that it has written this code in, it gets passed into a git diff patch that can then be attached to a pull request. So So basically last week I just kind of was trying to understand this framework, and I thought of like I was a bit confused as to how exactly to proceed, but what I ended up doing was basically trying to run it myself, and so it runs on Docker. So for my final this I have a this of like whenever we need to call this, like just for a particular issue, we can call this framework via Docker. So basically, like so that was last week. I kind of was finalized on this framework, and then this week I set up the whole framework with their instructions and I ran it. And the first kind of problem that I encountered was the fact that this had support for Olama, which is what I'm using to run my local model, and it had support for the Llama 3 model within Olama. But the problem was that the smaller Llama 3 model that I'm using is not like it was not giving good results. So basically, it was kind of running in a loop continuously. So then the first half of this week, I kind of tried to debug it, and there were like 3 small prompt changes and a few like code changes that I made, and that made it like fixed it, and I can get this like proper patch generated with my local model. So the first patch was to like kind of add some new functionality, and then the next issue was to like fix some buggy code, like division by 0 is not possible. So it does the same process and it ends up like with a good result here as well. So this is like the main thing that like I have this working, and I have an entire like documentation sheet of um, like how anyone else can basically run this in the sense that even for my project, eventually this needs to be run in the background, like as per my current plan. And then the next thing I tried to do was integrate this into my project. So basically, like I started to write a Python file where I would just create a contributor agent and have it like have issues in a list, and the contributor agent would keep trying to solve each issue. So for each issue, it would basically call this Docker container. So this is what I'm like currently doing as well, where basically up till now I was running it via like command line arguments, and like that's the first thing I tried to do was try to get this Python file to call the command line arguments, but that's not working properly. There's a lot of like I tried it via OS and some person. So instead, what I am hoping to use is a Docker Py SDK, like a pip installable package of Docker. And using it, I can use commands like container.exec run. So like the exact commands of basically having this Python file just call Docker and run that particular command, and in a way that the output gets stored like here. So like having the Python file do all of that. So that is the part that I'm currently on, because I'm getting like quite some errors in this, but it's possible like this package exists. I just need to figure out the like exactly right ways to call it. So that is what I'm currently doing. And then like my current plan is basically to have a contributor agent and a maintainer agent in this one Python file. And the contributor agent can use this framework, create a patch, give it for review with the maintainer agent, and then the maintainer agent can like choose to apply the patch or reject. And then the code repository also gets updated, and like once this basic kind of structure is created of both these agents and they're able to communicate properly, like the next thing for me to do would be I had like in the design diagram that I proposed, there was like once my environment was set up and the agents were set up, I think go for the personalization aspect of agents, where the like every agent having a sort of experience level, and then the more issues they solve, the more their experience increases, and kind of introduce all these metrics based on this. So this is like the groundwork for getting everything to work that I'm currently doing. And so yeah, I'll address any questions on this, and then I'll go to a few doubts that I have.
Okay, that sounds great. That looks pretty good. So did we have any questions for Sarrah?
So yeah, the like the current code is there on my like a fork of this repository of the oral GSoC repository, and within it I've created a new folder, and it's here. So like, this is where the current code is, and I'll write a blog as well to kind of document this work and better explain it. I haven't gotten around to it yet. I'll do it over the weekend.
All right. That looks great. So I see you have a fork of our GSoC repository and you're working on that. Okay.
So yeah, I did have a question as to like, so I have like these, like currently the framework is not in its final structure. I'm building up these like small components.
Yeah.
So should I just keep it on my local fork only, or should I create pull requests for this as well? Or should I wait till the final kind of structure to?
Yeah, I think you could create a fork now, or you could issue a pull request. Like you could do it now, and then like keep working on it and keep issuing pull requests every few weeks, just so we can go through it. Yeah, I just want to go through it and see. So yeah, I don't want to. Yeah, I don't want to leave it to the end because they get really big and the push is like huge.
Okay.
So.
Right. It's just that maybe some of these folders won't exist in the final one.
Oh like, well, yeah, it'll fix that though. It'll. Yeah.
I can just delete them later.
Yeah.
So I'll pull requests once like. So currently the Docker issue that I'm running into, once that is fixed, I'll make a pull request for the works.
Yeah. So the Docker is for running the agent or the agents, right? So it's
yeah. So yeah, basically like the autocode rover needs to run on Docker. I mean, it's not very much needs to also. It's kind of recommended by them.
Yeah.
But I did think like that was an easier way. So now the thing is that autocode rover is to set it up, you need to get the code via their GitHub. But then, as I mentioned, like I needed to make some tweaks to make it work with my model. So the code changes to that I have pushed to a fork of their repository. So yeah, for like my final project, I could do a few things. I could either have a setup procedure where people can clone my repository and make a Docker image from it, or maybe I could have a Docker image and publish it and just have people pull that. I guess the second would be easier.
Yeah.
But yeah, sometime later. So if once that is done, then the Docker image just needs to be there to for the like going from the issue.md file to the pull request.md file, and like everything else can be done locally with like my framework and my code. And this is sort of like an API call
right.
to the other. This is like the kind of structure I have, so I'll definitely be open to inputs on this, whether there's some easier or better way to, also credit the original makers of this framework. I've like mentioned them in the README files as well. But anything else, the suggestions.
Okay. So did we have any other questions for Sarrah? Oh yeah, that's the link to her fork of the repository. So that looks good. All right, thank you, Sarrah.
Thank you.
All right, so that's great. So Shubham, welcome, and Hussain, welcome, and Himanshu, welcome. So, do we have any more updates?
I have an update for this week.
Okay.
Am I audible?
Yeah.
I'll just share my screen just a second.
All right. Sarrah, could you unshare your screen? Oh, hi, Jess. So apparently Jesse's at the Boston NBA championship parade.
Is it visible now?
Yes, I see it now.
Yeah. So what I've been trying to do this week is, I've tried to define the work that will be done by contributor agents and issue agents and maintainer agents as it was proposed in my proposal.
Mhm.
So it was proposed that we'll have because I'm working on an agent-based model, so there will be issue agents that will be stationary in the in the graph or whatever model you can call it a model, and there will be contributor agents and there will be maintainer agents. So the approach was if these contributor agents and maintainer agents will move around in the grid, and if a contributor agent occupies the same cell with an issue agent simultaneously, then it will be assumed that in the real world or in the real case scenario where contributors are working on issues, it will be assumed that this particular contributor will be working on this particular issue with which it is simultaneously existing in the grid. So once that happens, that particular issue agent will be marked for review, just like over here. So in the step 0, you can see that this contributor agent found this issue agent 8 at coordinates 6, 5, and then this was marked for review. And I've iterated 50 steps for it now with 10 contributor agents, 5 issue agents. 5 contributor agents, 10 issue agents, and 3 maintainer agents. So now the problem with this is contributor agents are able to locate these issue agents and they can mark them for review, but the maintainer agents are not able to find these issue agents. The issue agents that are marked for review. And the same concept applies over here. If a maintainer agent occupies the same cell with an issue agent that is marked for review, then it will decide whether or not if it should be included with the code or not. So that is where the RL part comes in. But I've been facing some syntax errors and documentation errors with petting zoo because I don't have a lot of experience on multi-agent reinforcement learning for now. So I texted Himanshu about that, but I didn't receive any response.
Yeah, I saw Himanshu here earlier, but
yeah, did he leave anything? Because I had some doubts in creating the custom environment for multiple agents.
okay.
So I just wanted to have a meet with him, and then we could discuss it further.
Yeah, I don't know. He was here just recently, but I don't know. Yeah, but that's good that you've got that kind of up and running, and then it's not easy to use, I guess. Yeah, set up a meeting with Himanshu. He should be able to help you with that. And we did some things with multi-agent reinforcement learning. I like the approach where you have like these different agents, and they're kind of like you're looking at them at different time steps, and you're looking at their activity, and you're monitoring that. Are you putting it? Well, I guess I didn't see the structure of how you're kind of thinking of the reinforcement learning part. I didn't really see that.
For now, what I'll do is first I'll create a custom environment where I'll define an observation space okay, this is the particular grid where the agents will move around, and then I'll create an action space. Action space is basically where agents move upwards, downwards, and sidewards motion. So the reinforcement learning part will work in the we can call it the classic way, where the agents are different agents are rewarded for doing their jobs, like the contributor agents when they find issues and set them for review, they are given a positive reward, and the more rewards they find in multiple iterations or multiple episodes, they will eventually learn to locate these issue agents and put them up for review. The same goes with maintainer agents. Also, I proposed in the proposal that we'll have funding agents, and I'll in future, in the coming weeks, I will also divide these or classify the issues with respect to their difficulty levels, and contributor agents will also be classified with respect to their expertise levels. That was proposed in my project. Shall I display the flowchart?
That would be good.
Yeah. Is it visible?
Yes.
I'll just. So, oh yeah. So for now, the contributor agents are just contributor agents, but this is what I'm planning to do. They'll be classified with respect to their expertise levels, so advanced, intermediate, and beginners. And also, this part was already used in I think when Himanshu was working on this project, where the issues were divided in their levels of difficulties with Earth shot, Moon shot, and Mars shot. Yeah. So this is what I'm planning to do. Keep the contributor agents that have a beginner level of expertise will go for the Earth shot issues that are the easier ones. The intermediates will go for the Moon shot, and the advanced can go for the Mars shot issues. And then once they are marked for review, the maintainers can see if the code efficiency is greater than a threshold level and merge the PR, or they can set it for enhancing the code efficiency.
Yeah, so you've got this sort of where you're sorting it by like the agent's competency, and then they go for the type of task that is suitable. Yeah, that's great. And so the reward structure is like basically if you complete a task, you get a reward.
Yeah, you get a positive reward. Okay. Yeah, and if you don't, or maybe if you are trying to solve an already solved issue, you get a negative reward, something like that, because the agent's wasting time, something like that.
Right. Well, yeah, that's
I wanted to discuss these things with Himanshu actually.
Okay.
But I didn't get any response.
Yeah. Well, yeah, he's probably busy with other things, so.
No problem. Yeah.
But no, that looks great, and that's a nice flow chart.
Okay.
Yeah.
Thank you so much.
Hi, Shubham.
Hi, Sarrah.
Yeah. So okay, I had so in the flowchart you mentioned that the positioning, like what you explained, where the issue agents and the contributor agents when they come up in the same. So in the flowchart, it is mentioned that you use active inference for that. So like
active inference is I'll just say go ahead and say that active inference. My approach while making the proposal was active inference to locate the issue agents that will make the system more enhanced. Because as if we implement just reinforcement learning, then the agents will get trained only for solving those issues or occupying the same cells as issue agents. So my approach while making the proposal was that we can locate the issue agents with the help of active inference. Active inference would basically mean communicating with other contributor or maintainer agents and trying to figure out the possible locations of issue agents. That was my approach, but for now, maybe at least till the end of July or first week of August, I'll be working on the RL part, and then we can shift to active inference if needed.
Okay. And so like you mentioned that the current issue we're having is with the maintainer agents discovering the mark. Right? So maybe that is what I was going to suggest. I was going to point to the too many cooks paper where so the too many cooks paper have the recipe model, right, which is kind of linear. I was just kind of thinking of how the open source format is kind of linear, right? Once it's marked for review, then it needs to be so
as I mentioned, once it's marked for review, the maintainer agent's job is to check whether the code is greater than certain threshold value, maybe greater than 70 out of 100 sort of thing. So if it is greater than 70 out of 100, or if it's greater than a particular threshold value, then that is when it is merged into the main branch. Was that your doubt, or you asking something else?
No. Yeah, my doubt was basically just that I thought that the active inference part could, make this locating easier, especially which issues are merged, because which issues are marked for it. So
what I'm
I
trying
think
to do now is, because for now the models are the agents are working on their own. They have not been trained with anything as of now.
The communication
so once
part
they are trained, so once they are trained, maybe the system becomes more optimized, and if needed, we can implement active intelligence as well.
So thank you again. And it'd be interesting to fit active inference into this somehow. But I'd work on the reinforcement learning part first and get that down. Especially the reward structure would be good.
I don't think we implemented the RL model last year. It was just as far as I read in the README file, this was a future scope of the project, that including reinforcement learning with the agent-based model.
I think he just worked kind of refining Himanshu's model. So but there's stuff there, so that can be kind of you can look at that and use that as sort of a basis for.
Sure.
All right. Any other comments or questions? All right. So I know that Hussain, he sent a message in the Slack about some of the stuff that he's doing in DevaWorm. So I know he couldn't make it because he had to go to another meeting, but he's been doing some interesting things in DevaWorm land, especially contributing to some things in a project on imaging physics for microscopy images, working on the multi-physics stuff that we talked about last week, and then some things contributing to OpenWorm. So he has a fork of some of the OpenWorm stuff, and he's working on that. So I don't know where he is with that, but he might update us next week. So that's good. So I don't know if Jesse, I know he's at this celebration / parade or whatever. So I don't know if he has anything to say.
I didn't intentionally come here. It's not like we got interrupted on parade.
Yeah. Oh, okay.
I don't know if it's really going in the back. Can you hear me?
Not really.
Okay. Then I'll just say nice presentations, and I'll say more next time.
Okay, that's good. Yeah. All right. Morgan, did you want to say anything?
Great presentations. I've got some follow-up questions for Adama. I've been trying to reach out to my more VR people that I know use Unity to potentially give some advice and support. But I can follow up with her on Slack.
Okay, that sounds great.
And,
yeah.
And petting zoo. I do know somebody at it's called Pharma Foundation now. If we've got developer questions about petting zoo.
Okay. Yeah, I'm not sure what they're.
If that's helpful. I think it's Pharma Foundation.
Like pharma, like pharmaceuticals.
But it's spelled with an F.
Oh, pharma. Oh, like a farm. Okay.
So
Oh,
for
so
some
the
reason
zoo,
my
right?
Discord has decided to crash.
Oh.
But yeah, they have a good Discord community. I don't know if you're on that already.
I don't know, Shubham. Sometimes they're of mixed use or mixed utility in terms of finding out what's going on. So, but yeah, and just you can join it and see what's going on there. Then you'll have 1,000 Discords open. Yeah, I know. There's Discord bloat.
I've already got 1,000 Slacks, so why
yeah.
not?
Okay, thank you for the information.
Oh yeah. So just let me know. He has some advice on scripting. Visual Studio, yes.
Yes, it's Visual Studio and Unity.
Yeah. So I might need a little more detail in terms of what exactly. He's got some strong opinions, but he's the guy who runs the Unityversity.
That's what they call it, Unityversity.
Yeah, well, it's a Bay Area thing.
Oh, okay.
Or, it's like, but he calls it like it's called Unityversity.
Like media centric or medium centric, basic or meetup centric.
Yeah, well, maybe. Yeah. It's also called the Game Bridge Group because it's run out of the Noisebridge hackerspace.
Okay.
But anyway. But he definitely, he knows, like, the Unity team's all based in San Francisco. So he does have, good contacts. He's probably going to push you to, like, Lua. But anyway, if you're going to, for scripting. But it depends on what you're trying to do in your scripting.
Okay. So maybe I can give you the details by message or right now.
Whatever's most convenient. Yeah.
Okay. Thank you.
Yeah. Thanks, Morgan.
Yeah.
All right. Okay. So yeah, I'll finish up to. Let me see what we have in the chat here. Okay. Yeah. That's all. So I want to finish up today with some things about I'm going to use 2 examples of projects or sort of proprietary software that's reached what they call end of life. And then when they reach the end of life, either software can die, or if the organization is proactive and the users demand it, they can open source the project and community of users can take it over and continue supporting it. So, a lot of times companies will have like a software package, they'll have users, and then they'll say, well, it's not worth it anymore for us to support this. We're going to sunset this. So we'll have no new versions. We'll not support, security patches or whatever, any sort of updates anymore. And so a lot of times users, if they don't have enough users to really care, then it goes away. But if the users are really continue using it, then they will want to take that project and put it in their own hands and continue on. So the first project I'm going to highlight here is Atom.io. And maybe some of you are familiar with Atom.io. It's a text editor that allows you to do things like run different, different types of, it's a kind of like a coding editor, but it's also allows you to run different types of conversions to different file types. So Atom was run by GitHub, and they have on their blog this article about sunsetting Atom. So GitHub started Atom. It was a very useful tool for people. You could download it on your machine. You could make all sorts of, it was a very versatile tool. It was like Visual Studio, but also had elements of, different types of being able to convert your documents to different formats and things like that. So they made the decision to sunset Atom on December 15th, 2022. So what that means is that you basically, they stopped supporting it, and, I guess in this case, they did away with sort of the web presence, so you couldn't download it anymore. And they would basically have, relegate the project to a repository on GitHub, which then they archived. So you could do, you could access it technically, but it wasn't really something you could, viably use anymore. So they decided to do this. They basically, so they basically set this up, and they made an announcement to the community that they're no longer supporting it. And there are a bunch of sort of updates to this blog post. So if I'm using Atom, what changes can I expect after the sunset? So, there are a couple things you expect after a product sunsets. Some features don't work. Security updates are not there for you. Package management will stop working. There are other types of niceties in the software that don't work anymore. But you can still download the binaries, compile the code, and everything else. So, people were kind of upset about this, and so they formed this, there's this Atom community, which is what typically will happen is they take this software, and it was already open source on GitHub, and they'll spin it off to a community version. So they'll take the last version that was, created by the organization, they'll hand it off to the community. And so this is the Atom community, where you have an API, you have some community maintained packages. And so now people contributing to the community can update Atom as they want to. And so people would fork this Atom community repository and work on the software from there. So that means you can create your own forks and create your own versions and, update the projects appropriately. And so this is a comment in the Reddit for r/Atom. Any forks of Atom emerging? Is there going to be a fork of Atom that will be maintained? If you know of any forks, please share them in this thread. And so this is where people would report on these different forks because people didn't want to go over to VS Code because, VS Code is not, for some people, it's not a viable option, let's just say. And so this was one of the, links to a discussion where people were organizing. So this is a discussion board on GitHub where they were discussing sort of ways to create forks and ways to create new projects from what they were given. So what happened was this coalesced around a new project called Pulsar Edit. And so Pulsar Edit is this kind of reborn version of Atom.io. Pulsar, a community-led hyper-hackable text editor. So that's kind of what they took all of the functionality of Atom and they're moving it forward. And so this is pulsaredit.dev. You can download the software. There's documentation, and they're organizing themselves into a new community with, I don't know if they have a foundation, but they've basically taken all of the aspects of Atom.io and they're constituting it as Pulsar. And so I don't know if there are any other forks. I'm sure there may be some other forks I'm not familiar with. But basically, we have, basically you can, create a fork, customize it for what you want, if there's certain features of the software you want, and drive that development forward. So, yeah. So that's one example of this sort of community-driven sort of revitalization of something that's been sunsetted. I think it's great because, sometimes you have these tools that sort of have a cult following or a niche following, and organizations like GitHub or like what we'll talk about next, Mozilla, they don't have the resources or they don't want to devote the resources to driving that project forward anymore. So they'll, instead of just wiping it off the map, they'll turn it over to the community. The community then can drive future development. And, sometimes this isn't successful as a model. Sometimes people don't get together on things. Sometimes people can't work with the software. But in the case of Atom.io, they were able to do that and create a new piece of software with a new identity. And I don't know if they put a foundation together around Pulsar, but, it's good to see that it has new life. So the other thing I'll talk about is Mozilla Hubs. So Mozilla Hubs is this sort of VR environment that you can run from a server, and it's browser accessible. So this was very common during the pandemic, where people, conferences and other types of get-togethers would use Mozilla Hubs to feature like posters and get-togethers and meets virtually. And so you can build, Mozilla hosted a bunch of virtual environments that people could navigate with their avatars, and they were hosting all these instances on their servers. And so earlier this year, May 31st, 2024, Mozilla ended support for Mozilla Hubs. So they basically said, we don't want to do this anymore. We don't really have the resources. And so we are ending support for Hubs. And so this is unfortunate for the people who are still reliant on Hubs for various things. I just ran into a case where they were talking about running a poster session on Hubs, and I had to inform the organizers of this event that this is no longer a supported thing. So they were planning on using Mozilla's sort of default servers to host their event, and it turns out that those would be shut off by the time the event happened. So they were grateful that I told them about that, but change of plans. So what happened here was that Mozilla, as they're a very progressive organization in terms of open source, they put out an end of support statement early. This was, I think, put out in January or something, or even earlier than that. And they basically told people, look, if you want to have a community version, we'll offer a community version, and we'll send it to, if you want to do it, you can organize yourselves around it. And so there's been a very robust response to that. There's been a robust community that sort of evolved out of the users of Mozilla Hubs. They were right on it. As soon as they mentioned that there was an end of support, there were a whole bunch of people who got together. They had videos trying to work through the repository and basically figuring out how to host their own instance of the software, and then get things back on track. So this is the new foundation that actually resulted from Mozilla sort of ending their support. They had an open source repository. It was forked by this new group, and they actually started a foundation because Mozilla Foundation is a nonprofit organization. They support a lot of the activities that Mozilla does in terms of community software and other things. And so they started their own foundation called the Hubs Foundation, specifically devoted to developing this new instance of Mozilla Hubs. And so they've got some really good resources here on how to set up your own server, how to work with the software, and everything. So I think it's a really good example of how you can take something that's reached end of life and really put together some good community resources on how to move forward on it. So they have good documentation, they have good resources on how to host your instance. So, something like this, you need to host it on a server, all the assets, all of the environmental aspects. There's a whole framework, but you have to know how to host it. And so in the cloud, so they have these resources for cloud development on AWS and DigitalOcean. So they've picked out ways to do this in an affordable way, so if you're a small organization or a small interest, you can do this on your own. And so here's the GitHub organization where you have the Hubs Foundation. They have good documentation. Here you can read through. They kind of give you the tools and you build your own instance and you can host things on your own. So, it's not the same thing because Mozilla was hosting everything for free basically. But, if you put a little bit of investment in, then you can get back up and running. So that's, those are two, I think, good successful examples of software that's reached end of life and how you can extend that life if the software is useful. And so, yeah. Oh, okay. Hussain is back. AWS just released AI certification. So, yeah.
Yeah, that's right. Yeah.
All right. So, I don't know if Hussain, if you had your update, if you want to.
Yeah. Thanks so much. We're just having a quick meeting with the company.
Okay.
Yeah. So, Dick and I have been making some pretty good progress on the breast cancer tomography. The breast cancer tomography research. We're having a lot of deep technical discussions on the geometry for the Janus spheres. So, basically, just to recap everybody, this is part of the. Excuse me. This is part of the technology we're working with to come up with an innovative approach of steering X-ray sources and polycapillary architecture, polycapillary optics approaches to breast cancer computed tomography to create some new ways to scan and detect breast cancer tumors in women. We're hoping that if we can show that we can take advantage of the geometry of these, of how Janus spheres are particularly steered, then we can make the process more efficient, more effective, more comfortable, and leverage the new hardware, new tools for people to use in the screening process of breast cancer. I did show some images last week. I think I can just pull them up again really quickly. This is what we call the orthogonal system. So completely unrelated to orthogonal research lab, although kind of a nice coincidence there. But this is the orthogonal system seen in context. This is what it would look like. Breast cancer, as cumbersome as it is to get screened, to get detected, is difficult and sometimes not so accurate as we might think. We can imagine an approach where these sort of this sort of technology can be steered, can be engineered, can be manufactured to really ultimately reduce difficulties like the pain, the discomfort, the compression, as you might think, between the two plates when a woman is being screened for breast cancer. And ultimately, we want to see if it works and if things can turn out well. So over the past week and over the past week and a half, Dick and I have been having some pretty thorough discussions, specifically on the geometry and the mathematics behind the Janus spheres and the Janus spheres themselves. More so the geometry of how the X-rays are shot and steered and directed towards the Janus spheres, and making sure the geometry can be kept constant for all different positions, and ultimately optimize the approach so that the woman involved does not really have to compress their breast as much, so that the process will be a lot more comfortable, a lot more efficient, a lot more effective. And for me in particular, I have to have some very thorough discussions with Dick on the Janus sphere displacement and survey available crystals that could be involved, and continue some simulations with Topaz. So Topaz is the software, the simulation software for X-ray simulations. And we had to go through many different types of software, different types of tools, like Morgan had mentioned 3D Slicer. That can be really great for the image classification, analysis, not exactly for the simulations themselves. Like I mentioned Blender and like making donuts and stuff. Blender's good for some physics simulations, not so much for X-ray technology. X-ray simulations, not so much for that. But it was nice to be able to explore into it. Ultimately, yeah, it's a lot of stuff. My deck calls it like there are 12 different steps in front of me, but they all lead in different directions. So I have to keep track of all of them as we move forward with everything. So just trying my best to, for example, not get so, I don't know, like stuck, because it's a very thorough thing. It takes a lot of complicated, technical, precise knowledge from like math, physics, chemistry, chemical engineering, stuff like that. My undergrad was a physics major, but it's been many years, and it's quite a bit for me to step back into those ways of thinking. But ultimately, this is some very, very, very exciting stuff. I'm really happy to be involved at the intersection of like software, simulations, physics, engineering, and ultimately breast cancer detection and stuff. So yeah, like I've been studying some. I can share the PDF. I can't upload a file here. Okay, never mind. I can show the PDF. I can show the PDF of from an academic perspective what I'm looking at.
Okay.
That'll be just to give you guys a glimpse. Excuse me. All right, there we go. So I'm only sharing the like here's one text that I came across, found pretty useful. Interactive computer graphics. Top-down approach or shader-based OpenGL. Yeah. So by some fancy people, and like shader. For those of you who are familiar, when it comes to graphics processing, and that's for anything, whether it's like you're making a video game, making a movie, even doing like scientific research, right? Like with simulations and things. Shaders are like a fancy word for what the computer applies to material or some object or something on the screen to give it something. Whether you want it to look a certain way, whether you want it to have a certain like physics defined property, whether you want it to interact with the environment as you need to. So this is where the knowledge, all the cool knowledge from my math and physics courses and stuff in undergrad are really coming together. Where like not necessarily like applying to make video games and stuff, but like to actually perform physics research and stuff like that in a really cool way. So yeah, this is what I'd be using these sorts of equations and tools and techniques with Topus, with the simulation software. So you can also use it with Blender, with Unreal, with Maya. I think you can use it in Maya too, but it wouldn't be so effective. It wouldn't be so valid. Right now, legitimate scientific validity. That's what we need right now. Not making a video game. Yeah.
Yeah.
Excuse me.
Yeah, that looks great. Yeah, and shaders are pretty have a lot of application domains. So working with that, I think is great, especially with like VR. And there's a lot of crossover with computer graphics and VR and other areas as well.
With all the video games coming out, like you all see the trailer for GTA 6. Those are some intricate, precise graphics.
Yeah.
There's a reason it's taking years for that game to be produced from a graphics perspective. And even thinking about like limitations of like hardware, technology being updated as recently as new as it needs to be. I was even looking to NVIDIA's technology for medical imaging to see if we can make use of that too. So this is all very, very, very exciting stuff. So
I'm glad to see. Yeah, I'm glad to see it.
Yeah.
All right. Well, I think that's it for today. Thanks for attending, and see you next week. And if you have any questions, let's ask them in Slack and make sure that we follow up on them next week. And good to see everyone's progress.
Sure. Thank you.
Yeah, bye.